Video 3 on circle theorems. We're going to I'm going to show you some examples, some non-examples. We'll do a proof, and then you will do a proof, and then we'll do some interactive questions as well. So this is called angles in the same segment are equal. So what you can see here is just a few shapes that I can move around. What you'll notice is the angles ADB and ACB are subtended from this arc AB here. And we can also turn it upside down and say the angle DAC and DBC are subtended from this arc DC. So let's put some angles on the diagram here. So if I leave A and B fixed, so let's just put them down there, and I move this angle around, what you'll notice is angle D does not change, and neither does this angle here. If I hold those two angles still and I move A, for example, see what happens? They still stay the same, although they both change, they change together. And now, if we were to just turn this diagram upside down, you'd realize actually the other side is also true as well. So if let's just move this around here, you can see that the angles that are subtended from the same arc, so up here and up here, I'll just draw this on here just for your reference. So we're saying this angle here, it's not going to let me draw on it, so I'm not going to draw that. So what we can say is the angles in the same segment are equal. Now, what do we mean by segment? Well, if we take this as an example here, when you have a circle and a chord going through it, then you can say this is a major segment and this is a minor segment. The fact that you have major and minor is not too important in this specific case. Right, so here's just another interactive just to make it clear for you. So we have the two angles here, which are subtended from the arc AB. So another way to look at it is it's a chord AB, and there is a segment. So the segment's now shaded in. You can see that's the segment we're talking about. And then we can say, well, these two angles have to be the same. Again, in a real exam, you're not going to have this interactivity, so you'll have a bare bones diagram, so the chord might not be drawn. But if you've got something like this, you can say that angles in the same segment, and this is what we mean by segment, they're going to be equal. Now, the proof for this is one of those cases, like I mentioned before, where you can use previous proofs to prove later proofs. In this case, we're going to use something that we've already done before to prove this. So let's consider you have an angle ACB subtended from arc AB. What we can say is the angle down here is going to be 2x. So if I were to draw another arc there, or another angle, so ADB, or another angle AEB, we know that whatever we draw is always going to be half of the angle at the center. So you can just say that they are all angles in the same segment, so they are equal to half of the angle at the center because they are subtended from the same arc. So let's do some example questions of this. So find the values of W, X, Y, and Z. So you must pause the videos before we do the answers. So pause the video now. Okay, now I'm going to go through the answer with you. We can see that if we treat DC as our arc or our chord, well, then that means W and 35 have to match. And if AB is our chord, well, that means C and D have to match. So that's going to be 43 and W is going to be 35. Okay, second question. Pause the video as soon as you see the diagram appear. Okay, so you should have had a go at the question now. So we can see from here, if we treat this AB as our chord, I'll try to draw that on there. I'm not sure if I can. Yes, I can. So let's say that's our chord. That means that this angle here and this angle there are going to be equal to each other. We also know that this angle, this is just a straight line. And if we know that's 137, well, then that's going to be 180 minus 137, which is 43. 43. I'll just do a line there. So that's 43. And that's a bit messy. I'm going to clear this all up. So we can, let's just say that's 43. We can then say that y must be 43 as well. And we can then work out this angle here because we now have a triangle. So they all add up to 180. So we do 180 minus 43 minus 93. So that is going to give me 44. Now, because that's 44, we know that Z is in the same segment because if that's our chord, well, then these two angles have to match. So these two angles are going to be, so it's going to be 44 and 43. Okay. That was the third circle theorem, and I'll see you in the next video for the fourth theorem.